So our first keynote speaker, well, he's a celebrated one. He is the director of the Potsdam Institute for Climate Impact Research. He is a professor in Earth System Science at the University of Potsdam. What he isn't is unfortunately here today. But please, ladies and gentlemen, welcome this message from Professor Johan Rockström.
Dear colleagues, friends, I'm really sorry not to be able to be with you at this really important gathering. Carbon dioxide removal and all forms of negative emissions is one of the key components for any safe landing for solving the climate crisis. Why? Well, scientifically we know we're running out of options. When Antonio Guterres, the Secretary General of the United Nations, stated as a comment on the IPCC's sixth assessment that we're now in code red for humanity, I would argue this aligns with science. We are definitely in a code red, with 400 gigatons of carbon dioxide remaining in a carbon budget for a 50% chance of holding 1.5 degrees Celsius, where all the models that have this safe landing have built into them major upscaling of negative emission technologies, major assumptions on preserving carbon sinks in nature, and the ability to transform the global food system, you recognize how tight things have currently become. But it's even tighter because we live in a geopolitical turbulence today of unprecedented levels, where we don't only have a climate crisis, we have an ecological crisis. We're losing the resilience of the Earth system exactly at the moment when you want to have good buffering capacity. This is a fundamental worry which requires us to invest really hard on avoiding risks as far as we can. But we're also having the pandemic, a tail end of a global health crisis, which in itself is a manifestation of the Anthropocene and our rising unsustainable pressures on the natural systems on Earth, a zoonosis that spills over viruses through domestic animals to humans. And then we have the geopolitical crisis, the war in Ukraine, potentially a new world order, putting into question collaboration and trust in the world with massive humanitarian impacts. But the climate crisis is now a drama. We've reached 1.2 degrees Celsius of global mean temperature rise. It's not only the warmest temperature on Earth since we left the last ice age, it's actually more than 100% outside of the warmest temperature on Earth since we started developing civilizations as we know it. So the maximum temperature over the last 12,000 years has been a plus minus half a degree Celsius mean temperature, and we've crashed through that since over basically the entire Anthropocene era since the 1950s, and we're moving in a pathway that would take us to up to 2.4, 2.5 degrees Celsius by the end of this century, and that is nothing less than a point of disaster. But even at 1.5, which I'll be coming to, is a scientifically hardwired boundary level that we must avoid. So we're now, unfortunately, at a state where we scientifically must conclude that we are at risk of destabilizing the entire planetary system. The life support systems on Earth, the risk of handing over to future generation a less livable Earth than the Earth that we were born on. The IPCC now recognizes this, showing not only the urgency that is unequivocal, not only that we're threatening human well-being, but even the health of the entire planet, and that the window for a safe landing is rapidly closing in, but also emphasizing that it's not only about phasing out carbon dioxide and fossil fuel-based emissions, it's also about securing the resilience, the carbon sinks. It's not only reducing emissions, but it's also about removing emissions, where CDR comes in, but also repairing the Earth system. And scientifically, this has now been something that has come into place just over the past few years, that 1.5 degrees Celsius is not an arbitrary number. It's not a negotiated compromise with low-lying island states in the Paris negotiations. It's a real climate planetary boundary. When we go above 1.5, we shift from moderate risks to high risks. And high risks not only in terms of frequency and amplitude of extreme events and impacts, like heat waves, like droughts, like floods, like diseases, but also higher risk of triggering irreversible changes. The IPCC now recognizes this with the red embers diagrams. You see the column furthest to the left here, for example, showing on impacts on single large ecosystems like the tropical coral reef systems, that the risk levels, the high risk levels of causing irreversible damage is already down at 1.5 degrees Celsius. We have been working post-IPCC on this in a paper led by David McKay and colleagues at the Earth Commission, which is in final level of review, by the way. So this is a preprint version, mapping out the roughly 15 tipping element systems, at large biophysical systems that we know contribute to regulate the state of the climate system, but which also have multiple stable states. And you see here the red embers assessment of the scientific confidence of risk, at what temperature levels we are at risk of crossing tipping points for irreversibly losing these systems' ability to support a stable Earth system. And what you see here, that a number of systems, those furthest to the left in this diagram, are at risk from the scientific assessment we have today already at 1.5 degrees Celsius. In fact, some of them even below 1.5. And that is in itself such a warning signal that we have the confidence that 1.5 degrees Celsius is a climate planetary boundary. Now, that is the fundamental science support for a safe landing. But we know that already today we're unsafe. The heat wave in India, with the almost 50 degrees Celsius life-threatening temperatures, which is just a manifestation of what we've seen in British Columbia last year, but also in Pakistan, India, and parts of Africa over the last few years, and also in the latest scientific assessments showing that up to 3 billion people may already in the next 50 years live in regions that are basically unlivable because of average temperature levels exceeding what we can cope with from a health perspective. India has decided to shut its borders on export on wheat, as you know, as a follow from the droughts created for farmers due to this heat wave, which in turn impacts downstream on a food insecurity and a food crisis, which is also related to the Ukraine war and the rising fertilizer prices that are so dependent on natural gas production. But we also know that we may, over the next 5 years, have a 50% risk of actually meeting 1.5 degrees. Isn't that quite remarkable that already within 5 years we are at risk of crashing through the 1.5 limit? And that in itself is a signal of the urgency of now removing carbon dioxide, removing the climate forcing, the greenhouse gases that are causing the warming in the first place. We also know that the urgency translates to the need for much more dramatic policies. We have scientific evidence that all existing investments in fossil fuels must be terminated because they in themselves would be causing a permanent deviation from the 1.5 line. So we're truly in a point where we need to, find ways of accelerating and scaling the transition back into a safe operating space on climate. And this is now reinforced even further by looking at the big picture. This is one of those big pictures, the first time a climate model, the Climeworks model here at the Potsdam Institute, is able to reproduce the climate journey we've had on Earth over the past 3 million years, showing in green that we have never, during this entire Quaternary period, exceeded 2 degrees Celsius. As you see, the warmest temperature on Earth has always been well below 2 during this entire period. And the Quaternary is very relevant because it's only during the last 3 million years that we've had a planet roughly configured in terms of life support systems as the planet we know of today. But it's even more dramatic than this, as I'm sure you're aware, that the last 12,000 years since we left the last ice age is this extraordinary Garden of Eden temperature levels of plus minus half a degree. You see this very, very flat line, and it's only during this last 12,000 year period of climate stability that we've developed civilizations as we know it. Now, what we have to recognize is that the reason why the Earth system has been so gentle to humanity is not that we haven't had shocks. It's not that we haven't had volcanic eruptions and earthquakes and variations in solar radiation. It is, to a large extent, thanks to the resilience in the biophysical systems on Earth. The IPCC emphasizes this by concluding that 56% of the emission of greenhouse gases from fossil fuel burning in particular has been absorbed in the ocean and on intact nature on land. This is the world's largest free service to humanity and the world economy. But it just shows that removal of carbon dioxide occurs in the living biosphere already today. And it's only thanks to this removal that we haven't crashed through 1.5 since several years. Unfortunately, we're losing this capacity. We can no longer trust the biosphere to keep up that sink. This is a paper on the Amazon having the unequivocal evidence today, actually, that the Brazilian part of the Amazon has tipped over from a sink to source over just the past 10 years. So we need to recognize that technologies for carbon dioxide removal, whether we, so to say, assess them as risky or not, must be seriously considered, because we need to complement and support the resilience capacity of the Earth system. And we know that the price to pay if we fail is tremendous. This is just one example of in 2070, with a business as usual future continuing emitting greenhouse gases as today, we would not have only, as the black dots show here, very small regions in the world, very, very limited regions in the world in the Sahara Desert that have health and life-threatening temperatures. The hashed lines show the regions that would basically be unlivable in just 50 years' time, hosting over 3.5 billion people if we continue emitting greenhouse gases as today. And you see that this coincides, not surprisingly, with, in red colors, the most fragile states in the world. So you have a recipe for disaster if we continue hitting the most vulnerable with the largest climate impacts, with all the disruption, displacement, migration, and conflict that would be downstream of this impact. So when it comes to removal of emissions, we need to now take on a whole global perspective. We know that we've not bent the curve of emissions yet. So this is a really deep concern, because science has been quite clear that the only way to have a safe landing is not only to stay within the global carbon budget of only 400 gigatons, the budget that IPCC now has confirmed for only a 50% chance of successful landing. It's also that we have to bend the curve, essentially 2 years ago, to have an orderly phase out following the carbon law of cutting emissions by half every decade. So the pathway in the IPCC AR6 becomes even more dramatic the more we delay. So you see the green landing line here, which is essentially the carbon law, 50% reductions by 2030, landing by 2050. But as is the key for this conference that you're hosting right now, this will not be enough. And that is what is so key to understand, that the gray line here is what we tend to focus all our attention on, which is the pace by which we need to phase out fossil fuels, the carbon law, the 400 gigatons of carbon dioxide, the 50% reductions per decade. But that won't be enough. The brown to orange transition wedge here is the global food system, from the single largest economic sector as a source to becoming the single largest economic sector as a sink. This is an agricultural revolution which has to occur at the same time. It's built into the models. It's factored into the models to give us the carbon budget. But that is not enough, as you are so well aware, because the models also assume, and that is confirmed in the AR6, that we also need to start scaling negative emission technologies, shown in orange. And that is the topic for this conference, and we have no choice. This needs to be done in order to have a chance of holding the 1.5 line. And the numbers here are, which I'm sure you'll be discussing very actively, quite staggering. I mean, from 5 to 10 gigatons of carbon dioxide equivalent per year in carbon dioxide removal. But then not even that is enough, because the models also assume in green and blue that the carbon dioxide uptake capacity in the biosphere will remain intact. So we're talking of a really optimistic outlook, and where carbon dioxide removal forms a necessary part of a safe landing. But the pathways for just the phase out is so fast. I mean, this is taken from The Economist, showing the pace, even by just delivering on the net zero pathways promised by the big economies in the world. Just look at China here, which will peak, they've said, by 2030 and then reach zero by 2060. Too late for science, too late for the carbon budget, too late to hold the 1.5 degrees Celsius line, but it's certainly a transformational journey. So one has to recognize that the CDR technologies are likely to have to play an even more important role, because the likelihood of delivering of this phase-out pace is unlikely, and we have to be prepared for even further investments in holding carbon sinks and removal of carbon dioxide. So I'm quite satisfied, actually, having been concerned, concerned over different forms of CCS and BECCS and different types of negative emission technologies that we today in the AR6 are clear that CDR technologies are necessary. CDR technologies need to be scaled very rapidly, moving in light green here from basically now onwards, so that we can have any chance of reaching from the millions of tons that are piloted today to billions of tons that need to be scaled tomorrow. And that this needs to reach that scale within one generation and be kept permanent and be functioning within the world economy. Now we know that the levels here are staggering. I mean, to keep a 1.5 degrees Celsius line, we need to reduce emissions, shown here in the y-axis, by roughly 7% per year. That's that's kind of a revolution pace by any standards, but it still translates to a CDR or carbon dioxide removal level of between 12 and 15 gigatons of carbon dioxide per year to hold the 1.5 limit. So there's nothing less than a massive effort required. And of course, as you'll be discussing, the whole portfolio of options is very broad and can be applied, as far as we know today, across different, let's say, potentials of gigaton contributions, but also at different price levels for carbon dioxide. And there's no doubt in my mind that the price on carbon, the research on carbon pricing, is a fundamental piece of allowing and enabling scaling of CDR technology. And we must see much more of this and having a price on carbon matching the social cost of carbon, at least the 200 euros per ton of carbon dioxide, very rapidly, in order to enable carbon dioxide removal to start becoming a real option for investment across sectors in society. So basically, we're today working at a very high pace for a transition. Is the transition likely to succeed? Well, one light in the tunnel is that we are at very likely at this tipping point, kind of a social tipping point, where we're seeing a momentum, both in terms of awareness, in terms of competitiveness on renewable energy systems vis-a-vis fossil fuel systems, climate policy being increasingly ready for delivery, no longer negotiating the contents. What we're lacking is really the economic policies that can unleash investments in carbon dioxide removal, which also conforms and aligns with low risk and security. So the research in terms of finding policies for scalability, but also assessment of security of CDR technologies is of course, long overdue, but also incredibly important and needs all attention. So what you're doing over the coming days is so important. So good luck with your work, and looking forward to see the outcomes of these deliberations. Thank you very much.